Hello friends and welcome at my channel. Today I would like to talk about inverse functions. So what is the idea of an inverse function at all? If you remember, a function is a special connection between x and y value such that to every x you have exactly one y value. So the graph of a function would be something like that, because that means to every x I have here, I have exactly one corresponding y value. Okay, and if you remember, we're having something like that, or even just one dot here, which is also a part of a graph. It's not a function anymore, because right here we would have two different values. So normally if your computer discovers something like this, it shuts down, right? So that's the story. Okay, well, so we have a special connection between functions, but we also have to understand that sometimes we want to reverse these connections. So, for example, we are writing f of x equals to 2x. Okay, so that means I have a box. I'm dropping, let's say, 5 inside the box, and what is coming out is 10 because I multiply 5 times 2. And this is what f um, does to all the x values, so it doubles it. So the question would be, how can I get back from 10 to 5? So what is the opposite operation? What is the inverse operation in order to revert it? Okay, and the answer is, well, you can compute it like if you write it y equals to 2x, you just basically have to turn around the connection between y and x here. So you just have to solve it for x. I'm dividing by 2. I'm having x equals to a half of y. So I have to do the opposite. Instead of doubling the values, I have to divide it by 2. So that means, and we notice it, f to the power of minus 1, so this is the notation of x, the inverse function, is just a half of x. Let us do a table for the values. So fx and 2x, and you see, well, this is a line, so I have 0, 0, and let's say 2 and 4. 0, 0, 1, 2, 3, 4. Got it here. So that would be such a line. Okay, but what about x and a half of x? 0, 0, well, that's all right. And now if you put 2 as well, we're going to get 1. So 2, 1, 0, 0, it's the same point. Slightly different, isn't it? See what's happening? So this is f to the power of minus 1, and this is f. Okay, and they're somehow symmetric. Symmetric considering what? Symmetric considering the identity function, f of x equals to x. This is a huge property, very important one. Okay, so we are basically reflecting the graph of f on the identity function. Well, let's call it just id. id of x equals to x. The name is clear. The function doesn't change anything. So identity of 5 is 5. Identity of 3 is 3, and so on. And you see, if we put lines right here, it's going to be symmetric. So it's really nice. All right. So computing the inverse function means basically we have to rearrange x and y values. We have to solve our function for x. Is it always possible? Well, no, it's not. Does an inverse function always exist? Well, no, it doesn't. Okay. For these purposes, we have to define injection, surjection, and bijection. And I'm gonna do it in the next videos. Okay? Thanks for watching. See you guys soon. Bye bye.